Hello, everyone. I'm David.
And I'm Sophia.
Welcome, everyone, to techdaily.ai. And before we get into the tech, just a quick message.
Go for it.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more.
That's a great deal.
It is. If you're interested, contact info@techdaily.ai to get started today. Okay, so let's talk about a major comeback.
A huge one.
After years of silence, following that first big misstep, Valve is officially returning to the living room.
Yeah, and we have the announced specs for their second shot at the Steam machine.
The community is already calling it the Gabe Cube, which I love.
It's a great name. And it's slated for an early 2026 release.
And what we really want to do today is dig into those specs, the leaks, the analyst predictions, and figure out where this thing actually fits.
Exactly. How does this flexible cubicle PC, how does it stack up against a PS5 or the new PS5 Pro or an Xbox Series X?
Right, because that's the central conflict here, isn't it? Can this small, super efficient PC architecture really compete with the raw power and, the simplicity of console hardware?
Especially when that console hardware is so heavily subsidized. That's the big question we need to figure out for you.
Okay, but to understand this, you have to remember the first attempt back in 2015.
Oh, yeah.
That Steam machine was, I think Valve's words were, super incomplete. Why did it fail so badly?
It was really a perfect storm of problems, but it all came down to the ecosystem just not being ready.
The timing was awful.
Awful. The launch was delayed. SteamOS, their Linux-based system, was incredibly immature. And then Microsoft comes along giving away Windows 10 for free.
Stealing all their potential users.
Exactly. But the real killer, the biggest problem, was the lack of games. Developers just weren't building native Linux versions of their big titles.
So you buy this machine and half your Steam library was just grayed out.
Pretty much. It was a hardware solution for a software problem it couldn't actually solve.
And that's where the whole story changes, right? All thanks to the Steam Deck.
The Steam Deck changed everything. It proved that a dedicated Linux-based gaming device could actually work if you solve that software problem.
And by solving it, you mean Proton.
Yes, Proton is the absolute key difference maker for this 2026 model. It's a translation layer, essentially. It lets SteamOS run Windows games, those .exe files, almost like they were native.
So instead of begging developers to make a whole new version of their game for Linux,
you don't have to. Proton just translates the instructions on the fly, and boom, you have access to almost the entire Steam catalog from day one.
That's a total game changer. It basically eliminates the #1 reason the first generation failed.
It does, and the physical design, the form factor, it really reflects that new mission.
It's meant to disappear into your entertainment center. It's this compact little cube, about 6 inches on each side?
Yeah, built around a big, quiet fan. It's tiny compared to the PS5 or the Series X. It's trying to look like an appliance, not a PC. It's stealthy. But the real story is under the hood. Let's get into the silicon.
This is where that efficiency story really starts.
Let's start with the CPU, because this is where the Steam machine actually, surprisingly, has a competitive edge.
Over the launch consoles, for sure.
They're using a custom AMD Zen 4 architecture. It's 6 cores, 12 threads, and it can boost up to 4.8 gigahertz.
And compare that to the PS5 and Series X, which both use 8 cores, but on the older Zen 2 architecture.
So, okay, fewer cores, which sounds like a disadvantage.
It sounds like it, but it's not that simple. The newer Zen 4 architecture has much higher instructions per clock, or IPC.
Let's unpack that. What does ITC mean for someone who doesn't follow chip design?
Think of it like this. IPC is how smart each core is, not just how many you have. It's about how much work one core can get done in a single clock cycle.
And Zen 4 cores are just smarter and faster than Zen 2 cores?
A lot smarter.
Yeah.
So for gaming, where single thread speed is often king for high frame rates, those 6 faster cores will likely outperform the 8 older cores in many scenarios. Okay, so that sounds great, but there's a catch, right? The TDP.
The big catch. Valve has limited this CPU to a strict 30-watt thermal design power, a 30-watt TDP.
And that is incredibly low for a gaming PC.
It's tiny. The chips in a PS5 or Series X can pull maybe 50, 60 watts, maybe more. This 30-watt cap is all about keeping it cool and quiet in that tiny box.
So even though the architecture is better, it's being held back.
It's definitely being prevented from reaching its full potential. It's a trade-off for that living room form factor.
Okay, so a modern, efficient, but heavily capped CPU. What about the GPU? Graphics are what really matters for a lot of people.
Right. So for the GPU, they're using a custom RDNA 3 chip. It has 28 compute unit CUs running at about 2.45 gigahertz.
Which is basically a Radeon RX 7600M mobile GPU.
Exactly.
And if you just look at the raw CU counts, it seems like it's falling way short. The Series X has 52 CUs, the PS5 has 36.
Yeah, the PS5 Pro is rumored to have around 60. On paper, the numbers don't look great.
But it's that architecture difference again, isn't it?
It is. RDNA 3 is a newer generation than the RDNA 2 in the launch consoles. It's much more power efficient, it has more features. That helps close the gap.
So where does it land in terms of actual performance?
Analysts are putting it somewhere between an Xbox Series S and a base PS5. It's a solid 1440p machine, but Valve is aiming for 4K.
And they plan to get there with upscaling. Which brings us to, I think, the biggest red flag on the whole spec sheet. The memory.
Oh, the memory dilemma. Yeah, this is a huge concern. The machine has 16 gigs of DDR5 for system RAM.
And a separate 8 gigs of dedicated GDDR6 VRAM for the graphics.
And that separation is the key problem. It's a huge departure from how consoles do it.
So explain that. Why is the unified memory in a console so much better?
It's all about sharing data. On a PC like this, if the CPU has some data the GPU needs, it has to physically copy it from the system RAM over to the VRAM.
That takes time.
Takes time. Eats up bandwidth. With unified memory, the CPU and GPU are looking at the same 16 gigs of super fast GDDR6. There's no copying. They just point to the data they need. It's way more efficient.
Which makes that 8 gigs of dedicated VRAM a potential bottleneck.
A huge one. 8 gigs is already getting tight for AAA games today, especially if you want 4K and ray tracing.
We've seen this in benchmarks, right? On 8 big cards.
Absolutely. The frame rates can just collapse. You get stuttering and hitching because the system is frantically trying to swap textures in and out of that small pool of VRAM. It's the biggest hardware limitation they're facing.
And yet, they're still targeting 4K 60 frames per second.
They are, but leaning very heavily on AMD's FSR, their upscaling tech.
So how does Proton, that translation layer, hold up when you're pushing a dedicated GPU this hard? Does that add a lot of overhead?
It's uneven. On the Steam Deck, with its integrated graphics, SteamOS actually performs better than Windows sometimes.
Right.
But with a dedicated GPU, that advantage mostly disappears. The Proton overhead is real, and sometimes Windows will just be faster.
But the results are still pretty good, all things considered.
Oh, they're incredible. For some of the heaviest games like Cyberpunk 2077 or Returnal, the performance on SteamOS through Proton is basically a tie with a native Windows install. That's a massive achievement.
But not for everything.
No. For other big titles, like Forza Horizon 5 or Borderlands 3, Windows still pulls significantly ahead on the same hardware. It's an ongoing optimization battle for Valve.
Okay, but there's a really interesting technical detail here with upscaling, where this new architecture gives the Steam machine a future advantage over the PS5.
Yes, this is a great point. It's about FSR4 and the hardware underneath.
So the Steam machine's RDNA 3 architecture supports something called INT8 operations.
Which is just an instruction set needed for the next generation of AI-based upscaling. But here's the thing. The classic PS5, which came out early in the RDNA 2 cycle, does not support INT8.
So the PS5 might be locked out of using this more efficient next-gen upscaling tech, but the Steam machine can.
Correct. The Steam machine can, and so can the Xbox consoles. It's a subtle but genuine future-proofing advantage that Valve has baked in.
Okay, but all the tech in the world doesn't matter if you can't play the biggest games. We have to talk about the elephant in the room.
Anti-cheat.
Multiplayer games and their anti-cheat software.
This is still the single biggest software problem for SteamOS. The biggest multiplayer games, Fortnite, Call of Duty, Battlefield, GTA, Online, they just don't work.
Why not?
Their anti-cheat software runs deep in the operating system at the kernel level, and it's built only for Windows. It just refuses to run on Linux.
So you buy this machine to play the most popular games in the world. You can't.
Not on SteamOS, no. The workaround, of course, is that this is still a PC. You can install Windows on it and dual boot.
But the second you tell a customer to do that, you've broken the promise of a simple plug-and-play console experience.
Exactly. It immediately becomes a hobbyist project, not just an appliance you plug into your TV.
Which brings us to the value proposition. The price.
Yeah, the big one.
Valve hasn't given a final price, but every analyst expects it to be premium.
The estimates are somewhere between $699 and maybe even $999, depending on the storage size.
That is a lot more than a console. That's way above the $499 PS5 and Series X. And it's right up against the rumored $699 for the PS5 Pro.
And the reason is simple. Valve won't subsidize the hardware.
Right. Sony and Microsoft sell their consoles at a loss because they make the money back on subscriptions like Game Pass and PlayStation Plus and a cut of every game.
Valve doesn't want to do that. They're relying on their existing 30% cut from games on Steam, so you're paying the full price for that modern, efficient hardware.
But in exchange, you do get a ton of flexibility that consoles can't touch.
Absolutely. Instant access to your entire Steam library going back decades, full support for mods, for emulators, and maybe the biggest one, online multiplayer is free.
No subscription needed. Plus, you can just drop into a full Linux desktop if you want.
But on the flip side, the consoles have perfected the things you need to win the living room.
And this is where the Steam machine starts to look a bit shaky again. Let's talk connectivity and media apps.
Two huge headaches. First, the machine is only certified for HDMI 2.0.
When HDMI 2.1 is the standard for any decent modern TV, that means no 4K at 120 Hz, no variable refresh rate, at least not over HDMI.
The hardware can do it over DisplayPort, but your TV doesn't have a DisplayPort. It suggests they're still fighting with Linux driver support.
But the media app situation is, I think, even worse.
It's a nightmare. Because of licensing and content protection, most streaming services, Netflix, Apple TV, HBO Max, they limit browser playback on Linux to 720p.
Wait, really? So you spend $700 on this 4K machine, hook it up to your brand new TV, and Netflix plays in 720p?
Yes. That right there completely shatters the illusion of a modern living room device. It feels incomplete, just like the first one did.
So Valve has to get those official certifications for 4K streaming if they're serious about this.
If they want to be a multimedia hub and not just a gaming box, they absolutely have to.
Okay, let's wrap this up. Let's synthesize. This is a small, powerful PC for your couch. It has a better CPU and the entire Steam library.
But it comes at a premium price. And it's held back by a tight 8 gig VRAM limit. And crucially, no native support for the biggest multiplayer games or 4K media apps on SteamOS.
So the takeaway for you, the listener, is that this is really aimed at an existing PC gamer.
Right. Someone who already has a huge Steam library and wants that console-like experience in the living room, it's probably not going to convert a dedicated console player who wants exclusives and guaranteed plug-and-play simplicity.
So we said the first Steam machine failed because it had no games. Proton has now completely solved that problem.
The game library is there.
So does the success of this new machine now hinge purely on the price? Or does the modern consumer demand features like universal HDMI 2.1 and native 4K streaming apps, things that even the most flexible PC operating system still struggles to deliver?
And that is the real test we'll be watching as we get closer to that 2026 launch. It's a fascinating battle between PC flexibility and pure consumer convenience.
It certainly is. Until next time.